Before you start Project 5.6 and 5.7, you should reboot, make sure your CentOS is working properly, then shut down and remove your snapshot. Once it's removed, go ahead and take a new snapshot and name it before 5-7. Once that's done, start up your virtual machine and go ahead and do projects 5.6 and 5.7. Once Linux loads, go ahead and switch to TTY2 and log in as root. Here we're going to look at the file system using the dump file system command. And then the file system we want to look at, which is our volume group that we created, volume 1. We can use the shift key and page up to view more information and see the top of the screen. We could have also piped it to less. At the top it tells us to look at the inode count, and there's some other stuff here to look at, such as does the volume have a name and the UUID for the volume. This will probably be different for everybody on the unique ID. The reason that the FS tab uses the UUID in a few places is because if you install a second hard drive or you change the location of the SATA cable on the motherboard for your current hard drive, it may no longer be SDA. It may change to SDB or some other letter. In that case, if your configuration file is referring to /dev/SDA, it will no longer work because you moved the ribbon cable or the SATA cable on the motherboard. For that reason, lots of distributions are using a unique ID number. Now we could replace the dev VG00 volume group 1 with the unique ID number. To do that, you could record it down, but that's a long number. So I'm going to install a mouse support program for the graphical interface by typing in yum install GPM. I'll tap Y to install. I will then start the service by using the system control command, start, and the service name GPM. Now I have mouse support at the console. If I hit my up arrow key to bring back the dump command and hit enter, and if I use my shift page up to view the UUID, I can now take my mouse and use my left key to click, hold, and drag and select the unique identifier. Selecting it auto copies it in the mouse buffer. Now if I was to edit the FS tab file, and change this volume 1 to UUID equals, and click the scroll wheel, the center scroll wheel on the mouse, will paste the UUID that you highlighted on the other screen. So it makes it much easier and eliminates typos. Here I can hit escape, :WQ. I can unmount volume 1. I can use df-h to verify volume 1 is not mounted. I can then use mount-a to remount all file systems that's specified in the FS tab file. df-h, and now I see that volume 1 is remounted. So this UUID is unique to every file system. It's a random number that is put on the file system when it is formatted, and it can be used to represent that volume even if the drive is moved from one system to another, or the SATA cable is moved to another place on the motherboard. Now the UUID number is not very intuitive, so something else that you can do, you can create a label on the volume. With the ext 2, 3, and 4 file system, you have a tune to fs command. The -L will set a label on the volume. So we could label this simply volume 1 and then specify the device to set the label on. Now if I use the dump command, I should have used the -H to eliminate some of the extra information. Now use my shift page up. Here I see the file system volume name is volume 1. That's more human readable than this unique ID number. So I can use that in my FS tab file instead of the UUID. I'll go back and edit and change this from UUID to label equals. Just make sure the case sensitivity label has to be in uppercase, and then the volume name has to be however you typed the volume. So I'll set the label to volume 1. Now if I unmount volume 1, make sure it's not mounted, type mount -A, view again, we see that it is mounted. So there's several ways that you can change and make the FS tab more readable. One is by the device mapping, which is not recommended by Linux distributions because that SDA could change, like I said, if you move the hard drive in the system. So using a label or the UUID is the preferred method for production systems. Finish 5-6 on your own. The stuff I went over was beyond what is in the text, but is very useful for production systems that you may implement. So try to remember, always set a volume label. Starting into Project 5-7, it goes over quotas. Quotas are very useful. It keeps users from filling up the hard drive on the server. A Little Rock man, back in the late 90s, early 2000s, when Napster was still out, downloaded, he searched for basically Asterisk, all music on Napster, and started downloading it. He saved it to the company's server. They didn't have quotas at that time, and it filled the server up, locking up the server. The server also housed their web presence and sales application, and shut the company down for 3 days, costing $1 million in sales. So he is eventually fired. I say that that's really a bad way that the administrator was running everything on one server and did not have separate partitions for the users, allowing them to fill up the C drive where everything was housed and shutting down the server. But modern OSs have the ability to set quotas and limit users. Linux has had that for a while, but they were using an old NT4 machine in that business that the person was using. So here we're going to use chmod and set all permissions on the new mount directory. And then we're going to switch over to another terminal window, log in as user 1, secret as the password, and we're going to create a new file under new mount called sample file that uses one inode. Every file name that a user creates, like I said, uses one inode on the file system. So we can see that when we go back to setting quotas for user 1, that there is a file for that user. We need to turn quota support on for the file system. That'll be editing the fs tab file. Going to the volume SDA5, and at the end of defaults, I'm going to put a comma, and we're going to put USR quota, comma, GRP quota. I've seen several students transpose the S and R or R and P, so watch out if you have dyslexia and transpose some letters, you'll get an error. So I'll write and quit, and I'm going to remount the file system. That reloads the file system and loads the two kernel modules for quotas. Now to turn quotas on, you run a command called quota check. With several switches. You could research these switches, but if I ever turn quotas, I just search the internet on how to initialize quotas and retype the string, because I'm never going to memorize that many switches on something that's normally set only once on a system. Now if we look at the files, we see we have a new file, a quota group and a quota user. We also see the ownership, that we have sample 1 or sample file is owned by user 1. It is no space though, so it's not using any data blocks. Now, since quotas files are generated, we can turn the quota system on, loading it up into RAM. Again, all of these commands in the switches, and you can easily look up in a book or search the internet to figure out how to initialize quotas and then turn it on for the system. Next is to edit the quota for a user. It's the ed quota command. This one you may want to become familiar with because you may use it day to day on a production system. So ed for edit and quota, -u for username, and we type the username that we want to change the quota on. Here the line is wrapped because our console can't show, so we got to pay attention. File system is under the SDA, blocks are under 0, and so forth. I have it circled and arrows drawn on the picture where this hard is for this 0 down here. So you got to be real careful when the lines wrap. So I'm going to insert and go to the SDA5 line. The number of blocks you can't change. That's read by the operating system and what size files are being used. The soft limit is how many what size files can be created before the user gets a warning. They also have a grace period. Once they exceed the soft limit, the default's normally 7 days. After 7 days, if they still exceed the soft limit, they are locked out and cannot create any more files. The hard limit, 60,000 here, or 60 meg, they cannot create anything over that amount. So they have a little slush area from 50 to 60, or 7-day period, that they can go over that amount. Now, you don't have to fix the spaces or anything. I'm just trying to make it look a little bit better on the screen. The soft limit here for inodes, they can create up to 300 files, and then they have a grace period of 7 days if they go over that to get it back down below 300. And 400, they cannot have more than 400 files on the system. So I would escape, :WQ to write and quit. Now I'm going to run the report quota command. And see that the root account has no quota set. User 1 has their quotas, 50 meg soft limit, 60 meg hard limit, and then 300 files soft and 400 files hard. We have a used 1 because sample file is owned by user 1, so it's showing that file is created. You should be able to complete the rest of the lab on your own, and then you will be done with this week.